Now I'm going to do a demonstration. I'm calling it the wave packet interference. This is a topic that we learn in physics. What happens to a wave, in particular a wave packet that comes to an interface and reflects off the interface, and how do we draw the progression of the development of the combined wave of these. So in my case, what I have is I have a triangle that I made from a piece of paper, and then I made all the triangles the same length. I made the base of the triangle. 28 centimeters, and I made their height 10.5 centimeters. So it's sort of random. You can make a bunch of pieces of paper that have the same dimensions, and you can make them whatever you want, and you can make them any shape that you want too, as long as they are all the same shape. Right, and then what I did is I decided to cut certain length of the paper because I had so many copies of these papers. So for you today, I have about 7 copies of the papers that I've made, and then I'll actually cut them like this. So in my case, I've cut them every 2 centimeters, and then I cut another piece of paper every 4 centimeters. Then the next one 6 centimeters, and the next one 8 centimeters. So since half of the length is going to be 14 centimeters, right? So since I did every 2 centimeters, I had to cut 7 pieces of paper in order to cut half of them, all right? And then first I'm going to illustrate what happens to the wave packet. So of course the original one is going to be this one, right? So I'm just going to draw this piece of paper right here. Imagine this wave is coming like this. Right? And then it's headed this way, so it's a wave packet, and now it meets a certain interface, right? A certain interface right here, and it's going to reflect off the interface. So what are the developments of the wave packets that form as this reflects off the interface? So if it is a hard interface, when it bounces back from it, there will be a pi radian phase shift. In other words, the pieces of the wave will reflect downward. If it's a soft interface, if it's a lighter medium than the incoming medium, then there will not be any phase shift. So first I'll illustrate to you that medium is a lighter interface. The medium here is a lighter interface than here, so that there will be no phase shift. You know, or in other words, it might be a movable. So it might be a wave packet, maybe in a string like this. Right, and then there is a ring like this, and then you put a rod, right? So if the ring is movable, and then the reflecting wave has no phase shift. So as long as there is another medium here that is a lighter medium than the incoming medium, or it might be a movable interface, right? If the interface is movable, then the reflecting wave has no phase shift. So first I'll illustrate the no phase shift. So this is the first wave coming in, right? Then the next one, what I did is I sliced it here. You can see right here, I sliced it. So it's going to look like this. You can see a little slice of it is missing there, right? Over here. So then what I did is that slice is here, right? So that slice is going to come back. So all you do is just cut a piece of paper that's that long. Then it's going to be coming back, and it's going to be you just draw that, right? And it looks like this. So what happens to the combination of those 2 waves when this comes back to that? So basically, this gets added to that, which means the 0 added to anything is itself. This gets added to itself, so you get this. So essentially, it's like adding this triangle, right? This color here. We can call this, we can do this in blue, right? So it's like adding that blue triangle here, right? So then the combined wave looks like this, and like that. You see? So essentially it's like basically taking the piece of paper and then taping it over here. So when this wave bounces back, it gets added to this, And so you essentially can tape that small triangle to this, so the combined wave is going to be up, down, and then a straight line. Okay? So this will be the second wave packet. The first one I'm calling the original one, right? So then it's just going to be like this, and then straight like that. So then a little bit time later, right, as the rest of the wave is coming and more of the wave has bounced back, so then you get something looking like this. Now, this is the next wave that you have, right? And then it gets added to that. And then you can erase this one, right? So the combined wave will look like that now. So this is what's happening as this incoming wave and the incoming wave and the reflected wave. If the reflected wave has no phase shift, in other words, it doesn't reverse itself, then the combined wave will look like that. So this is a great way that you can do an experiment with students. You can get different shapes, not necessarily triangles. You can get shapes that look like sine waves, wave packets like this. And then students will have a hard time visualizing what is going to happen. So just have them make different pieces of paper, again, same length, same dimension, everything, and then have them cut slices of that wave packet, 2 centimeters, 2 centimeters, 4, 6, 8, like that, and then have them draw it and then tape it on top, and then they will see the progression of the wave that will develop. Okay, so this is a really good demonstration you can do. The next one that I have, I've actually taped it already so you can see the pattern. So there's a little bit of peak here, it goes up, then down. So incoming wave and reflecting wave. So it looks like an interesting combination of the two. So over here, it's usually plateauing, right? Well, then what's going to happen to the next? So this is the fourth one, okay? And then we have here the next one. Well, this one is a bit tricky. Look at what happens. When you cut it, it looks like this. So this is the interface right here. When you cut it, and if you tape it like this, it's going to go like this. And if you're not careful, you're going to think the wave goes like this, you know? So it's going to look like the wave is going to go like this, then up, then like that. If you literally just go like this and then tape this to this. But this doesn't make sense. So basically, the original idea is that this wave is coming backwards like this, right? And then so you have a piece of paper. Literally what's happening is that you've got one wave that's looking like this, right? Comes down like this. And then you have the other piece of paper that goes like this. So this one, when added to this, of course, should make it go up, right? This one, when added to this, should make it go up. Now the zero, when added to this, should make it stay here. So there shouldn't be a bump like that. This point should be down here. So how do we do it? How do we do it? Here we didn't face that problem because we hadn't reached the peak yet. Right? So what you have to do for this case is the portion of the piece of paper that's over the tip, you have to cut that portion out like that. Okay? So I'm going to cut that portion out. So now it looks like this, right? And then what I'm going to argue is that after that, I'm going to bring this down. Okay, bring this piece of paper down like this. Okay, so what I'm going to argue is I'm going to flip this like this and then bring it down. So I'm going to argue by the time you get to this point, you should basically get the original graph. So from here, I'm going to draw a straight line. Okay, so instead of having this corner, I'm going to have like this, from here all the way to here, straight like that. You see? So then that is the correct graph. It goes like this, the graph looks like this. like that, like that. So this one I'm going to call 5. Incoming, outgoing wave. Okay? So you shouldn't have that piece where it goes like this, zigzag like that, right? They should be adding smoothly. And so in order to do that, you need to cut the portion on the opposite side of the peak, cut that portion out, and then go down, and then you can see where the remaining little portion, put a dot there, and then connect from the top there to here. So the overall wave is going to look like this. Okay, so now let's go a couple more. Okay. So this one, the next one, I've already done that, where I've cut this portion out. So then I have here, this is the interface. So you see I've cut that portion out, and where is that portion? See, that was going to be right here. It was going to go like here, but I don't want that piece. So then all I do is reverse it, put it down here on top of the first one, right? Put a dot here. Put a dot here, and then connect those 2 points with a straight line. Okay? So then the combined wave will look like that. Then I can erase this portion, and I can say, okay, so this is like this, like this, like this, the incoming wave and the reflecting wave. So this is number 6. Let's go a couple more. We have here the next one, and I'm going to draw that here. This portion which would have gone over here, I'm just going to flip it, go down here like this, and then connect those points. And of course, I would use a ruler to make this better. Okay? Then get rid of this. So this is the 7th. So the original, and then I have the original, and then the 7 more. 7 more frames of the development of this wave packet. So then 1, 2, 3, 4, 5, 6, 7, and then I have 1 more. Okay, and then the next one is essentially just going to be like this. Just half of the wave is left coming in. So then you're going to have like this, right? So it's going to peak all the way there, but then of course it's basically like this, literally. 2 waves that look like each other that are being added. So over here it should double, over here you should go back down to 0. So it just should be a straight line like that, you see? So then you go like this, you cut it, and you go like this, and then you just put a point wherever the top is, right? You just put a point right here, and then you put a point, of course, where it starts here, and you connect those 2 points. So you're just going to have, connect those 2 points. Okay, and then erase this. So the wave just doubles itself. Right? So this is 8. So over here, if it was 11.5 centimeters, over here should be 22 centimeters. Right? 22 centimeters. And then this one should be 14 centimeters because the base was 28 centimeters originally. So it just basically completely duplicates itself. And then after that, you get a mirror image of what's going to happen here. It just continues to develop until the waves completely pass each other. At the end, when all the reflection has done, you have a wave that looks like this that's just traveling to the left, right? So if we did 7 more frames like that, and then the last one after that will look like this, and then the wave will just come back just the way that it came in, okay? So then what's going to happen if you go meet a medium that is heavier than yourself, or you go and hit a wall, basically, instead of a movable surface like this, where the ring can go up and down, we can just have a wall and then have a ring like this, right? And the wave coming in and bouncing back, and then this is a wall. So this is an immovable object. So either it could be a heavier medium or immovable, and then the reflected wave will have a phase shift. So let's see what's going to happen. So I did a similar thing, similar size paper, similar shape paper. Then I cut it every 2 centimeters, but then now I'm going to flip it. I'm going to flip it downwards. And then, so let's see what we get here. Now you cut 2 centimeters, and then now you reverse it. So essentially it looks like this, right? So what's going to happen? When you reverse it, this portion cancels. So this portion here looks like this. It looks like a little piece, but it's inverted downward. So you have something looking like this. Goes like this. Goes like this. So this is on pole 1. Okay. So you see, since it's being reflected downward, there's a phase shift. So that portion that you cut reverses itself. This one cancels this one, and then you get 0. This one gets added to this one, and it just stays itself. So what's going to happen? Since 0 added to anything is itself, this one cancels this, and then you connect these 2 points. So it looks like this. Okay? And then so the combined wave looks like that. It's an interesting shape. Like that. Like that. It's like a chunk has been taken away from the original graph, right? So this is number 2. The incoming and the reflecting wave are interfering with each other. Okay? So again, this portion cancels that portion, and you get itself. This portion gets added to that portion. It keeps it itself, right? And then you make a straight line down. Then you cancel this one, and then so the wave looks like this. Like this, like this. So this is 3 incoming, outgoing waves. Okay? So then the next one after that, so it becomes fast. Once you do a couple of these, you really get the hang of it. All the way to here. And then of course here, you go here, then a straight line. Erase these. Okay, incoming, outgoing wave. So you can see it goes up, it goes at its original angle, then it slants downward until it goes to 0, right? So it's a very different, the wave packets that you get are way different than when there was no phase shift, right? Then the next one, now this one is a bit tricky because now I'm gonna pass the peak. So look what happens. It goes like this, okay? Okay, so then what's going to happen here? Now, since the left side of this is past the peak of this, right, is to the left of that, we have to do a bit of a trick similar to what we did when the same thing happened to the other one, right? Remember we cut the piece of paper like that? This one added to itself should be itself, right? And then what's going to happen after that, these ones are going to be subtracting from that. So essentially, I can't do what I was doing earlier for this one. I was taking this and I was just drawing it. And then what I was saying was, it was like this. 0 added to itself is itself. Then I was just drawing from here to here, the dot, and then I was going like this. Now, if I did the same thing here, if I connect this to this, and then I say this one cancels this, and then I draw a straight line like that, I'm going to think that the graph goes like this. This one cancels itself, and then it's going to look like this. I'm going to get that result. So that's not right. So you have to be a bit careful. Once you pass the peak, you have to do a bit of a trick. So let's draw the original one like this. What I've done is I've cut this piece, this little piece, right? The little piece basically past the peak. So that piece is here. So then what I'm going to argue is that this one is going to go like this. And it's going to be subtracting from this piece because since it's negative. So all you do is you flip it. And since it subtracts from that piece, you put it here. And you just basically end up getting a triangle that looks like this. Right? Basically, this triangle fits in that triangle and then cancels that. So you essentially cut that piece out. You see? This one cuts that piece out. And then so this one plateaus. From here, this one cancels that one. So you get 0. And then from that point, you connect to the bottom. So this is going to be the 5th frame. So actually you develop a plateau on the top. Right? So if we didn't do that trick, we would have thought that it's going to go up. We would have thought that it's going to go up and then it's going to immediately come down. Right? Which is wrong. So you have to do this piece, the little piece which is going to cancel that, and then do the plateau and then come down from there all the way to the bottom. So this is our 5th frame, incoming, outgoing waves. I have 3 more frames left. So I've done the same thing for those ones. So now the next one, it looks like, okay, looks like that. And then I've cut this piece out. Right? I've cut this piece out. So then I go over here. I put it over here like this. Then you can see that it will plateau. Like that. From that point, this one will cancel that. So you will get here. Then you can connect to the base. Then you can erase all these. Just like that. Erase this one. Then you're going to have like the wave looking like this. Incoming, outgoing wave. This is number 6. I've got 2 more left. And then you can see what's going to happen by the time that we get halfway. Right? Okay. And then take this one here. Go like that. Then you can see the plateau. Canceling, and then from there connect to the base like that. Okay. So this piece cancels that piece, and then by the time you get to the end, it gets 0. So then you can erase this. Goes like that. Okay, so we can call this one number 7. Incoming, outgoing wave. Okay, compare this in the video, compare this, pause it, and then compare it to the ones that I did where there's no phase shift upon reflection. Compare them and see if it's making sense now that you've got both of them. See how they are different, how they are similar. Okay, now by the time you get halfway, essentially you get this, right? So a wave looking like this. Each wave will completely cancel the other wave at all points, right? They will always be canceling. So this one will cancel that, it'll be 0. This one will cancel that, it'll be 0. So what's the resultant wave? Just a straight line. Complete destructive interference. So the wave will just look like a straight line for a split second, right? So the wave packet looks like a straight line. Of course, it's a little bit shorter than this, okay? Okay, so this is the 8th one. After that, the 2 waves will start passing each other, and then they will look like mirror images of these ones. 7, then back to 6, back to 5, back to 4, back to 3, back to 2, back to 1. And then what's going to happen, by the time that the 2 waves have completely passed each other, you're going to end up with a wave that's the opposite of this, right? So it's a mirror reflection of this, but in the inverse way, right? Why? Because the bottom one, the one that's reflected, has done a phase shift, so that begins to dominate. The bottom one begins to dominate. So when you're doing the other ones, you're going to find that they are not only mirror reflections of this way, but they are inverted, right? So by the time that it ends, the resultant wave you have should look like this, and then it should be going backwards like this, way at the end. So that's going to take 7 more frames, okay? So now you can see a good demonstration you can do to do this wave interference. If you don't want to do so many frames, you don't have to necessarily cut it every 2 centimeters. You can cut it every 4 centimeters, and then you don't have as many papers to connect. So you can do as many frames as you want, as little frames as you want, but it's a really good demo that you can see how wave packets interfere with each other, and you can try different shapes as well, okay? Thank you very much.